Yeah, good evening everybody. So I'm going to talk to you about lessons from Infosec incidents tonight. So what can we learn from the variety of things that have happened to other companies so that they don't happen to us? And I was looking for a picture to kind of illustrate fail, and I found this, and I think it's not Infosec, but it's a good example of a security problem. So you got a great big gate there, metal spikes on the top, that's all brilliant, but all it takes is to know the right secret and you defeated the security. So we don't want to be in a position like that really. So hopefully we can learn something from some of these things. So who am I? Well, my name is Robin Minto. I'm a technical architect, software developer. I work for a company called Buybox. We're a logistics supply chain management company, technology based. We work globally, but we're based in the UK. I've got a distributed team of software developers, of which I'm one. Always looking for new people, of course, as is everybody nowadays. I've had an interest in security probably almost as long as I've had an interest in computing. So I don't know if anybody recognises what these are, but these are BBC B micro computers, and we had a lab very similar to this in school. And me and a friend would sit down, and in those days you'd get a magazine to get your source code. You couldn't get it off the internet, and one of us would be reading it and the other one would be typing, trying to get this software into the computer. And the bit of software, I remember one bit of software we acquired that way and built into something bigger. We used to take over the entire network. Every single machine was singing a song, displaying some cute graphics, and the teacher was basically standing there, not really understanding what was going on, completely bewildered. Yeah, and that mate of mine is now on the security team at Google. So, quick show of hands, but do something slightly different. Oh, no, that one. Can you see that? If you go to that URL, I'm going to do it. I'm going to do a poll with technology rather than a show of hands. See if this works. So http etc.ch/5v small v small z large w. Have you got that?
Not sure I trust you. Not playing. It's safe for work.
It's all safe, I promise. This is not one of the lessons. No, I mean this is really just a bit of information gathering, and I can often I'll get people to put their hands up, and that's great if you look around where I am. But for you guys, you won't know what the score is. So with this, I can show the results, and everyone will know. So has people got that? Okay, I'll start then. So, question 1. What's your primary role? Are you a developer, architect, QA? What? Oh, look at that. It works. What else have we got? Oh, I'll never guess what that top answer is. Are we all done? Let's go with that. Bingo, software developer. Oh, we've got some other. Oh, who's another? What are you?
Scrum Master developer.
Okay. You could, yeah, okay. All right, cool. One more question. What's your primary language? Now this is .NET Southwest, so, oh.
COBOL at the top.
I didn't put COBOL in the list, so. Are we all in? Oh, look, there's a latecomer with something in there. Oh, look at that. Any more for any more? Okay.
What's the other?
Who's the other? What are you?
I still do a lot of VB6 as the primary one, but I do VB.net as well.
Okay,
But primary it's VB6.
fair enough. Fair enough. Right, okay. So I will put that aside for a moment and carry on. Thank you very much for that. That's helpful for me. Hopefully helpful for you. All right, let's get rid of this. Let's get through that. Right. So why do we care about security? Lots of reasons, really. People are trusting their data to us and our applications. That might be our personal data, that might be company data. We really don't want to be in a situation where our company's in the headlines like this. This is VTech in 2015, where they lost loads of personal details about lots of their customers and their customers' kids, and it's not a great place to be. There's data protection regulations out there now. They're getting much tougher next year with GDPR. I don't know if you're familiar with that, but bigger penalties, people will start going to jail potentially. The board will be very interested in what's going on as well. So hopefully some of that will mean that we do improve, but we need to know how to improve. Another reason we don't want to be losing our data. I don't know if anyone's familiar with this website, but you know, this is a breach aggregator from Troy Hunt. You know, you really don't want to end up on that list of people who've lost their data. So how are we doing in terms of security? Well, not brilliantly. 4.8 billion records lost since 2013. Now, I left that slide in there, that's from last year. Actually now, it's more like 9 million. And it's getting worse because the frequency is increasing as well. So, lesson 1, know your enemy. This is your typical hacker. Everyone knows this person. Always wearing a hoodie, lots of code in green. But it's a bit more nuanced than that, I think. So, you know, it might be a script kiddie, or, I mean, it could be a disgruntled employee, hacktivist, could be organised crime, industrial espionage, even up to nation-state actors. And I think, you know, you really need to think about that, because I think Sony probably didn't think that they were going to be attacked by a nation-state in the form of North Korea just for producing a movie, but that's actually what happened. Similarly, the BBC also had North Korea trying to prevent them broadcasting a documentary on North Korea. So, you know, you can be affected at all sorts of different levels, and I think it's important to think about that. There's a 25% risk that it might be someone inside your company that's going to cause you some problems like this. This is all statistics from the 2017 data breach investigations report from a company called Verizon in the US. They're a big telco. I mean, one of the big motivators is obviously money. 73% of breaches are financially motivated, so another big motivator. And so threat modelling is kind of the big thing that you want to think about here. And I've heard a great expression which I really like, which is evil user stories. So you're doing your Scrum and you've got user stories. Well, actually think about it from an evil user perspective. And I think that's really powerful. So what about incidents that we can learn from? Well, here's one. William Hill, taken off the internet from a DDoS attack. I'll talk a bit about DDoS and what that is in a second, but again, this speaks to that portrayal of your hacker in the hoodie, and often it's not just your evil criminal mastermind. Sometimes it's just a teenager in his bedroom. This is a young guy from Worcestershire, charged with running DDoS services, 18-month suspended sentence, probably got a lift home from court by his mum, that sort of thing. So what is DDoS? Well, you've got your attacker in the top corner there, you've got your web server in the bottom corner there. The attacker's got a control server and a set of zombies. He sends a message to his controller, that sends some messages to all of his zombies, that floods a load of requests towards your server and basically just takes it off the internet. Those zombies might be servers on the internet or PCs in people's homes, or it might be even routers, IoT devices. So denial of service is used by script kiddies to knock their friends off the internet when they're playing games, but it could be to take you off the internet, stop you from doing business, blackmail you into paying them a ransom to let you kind of continue your business. I mean, some of these guys just knock each other off the internet just because, just for shits and giggles, really. They might just be offended. An interesting technique is to use denial of service as a distraction. So you take someone off the internet, but actually you're actually breaking into a system somewhere else. So that's a big distraction. I mean, you can defend against this by having a traffic scrubbing proxy in front of your website. So something like Cloudflare or Akamai will happily take your money to take that bandwidth away from you, and that can be incredibly effective, but could be quite expensive. So I mean, this is going to be the biggest deal if you're a big financial company. So William Hill mentioned there, bookmakers are a big target for this, because obviously as soon as they're off the internet, they're losing money, and the criminals know that. One of the other things I was going to show you is a good demonstration of attacks. Now this is a great illustration of the attacks that are going on at the moment. This is from a company called Norsecore. Great looking map, great to show to the boss. Not quite sure how effective it is or how real the data is, but there you go. Looks amazing. And one thing you can do on top of that is you can make your own. So here's the .NET Southwest attack map. This is all completely real, nothing fake about this. And you can even customize the sounds.
China, 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 China.
So there you go, your very own attack map, and that's on GitHub. It's not mine. I didn't write it. I can't take credit for it, but that's great. Show that to your boss. Tell him you're under attack. Ask for some more money. So the next lesson. Cover the basics. Can anyone see the problem with this? I'm logged in, and there's a little tick there that shows that I'm logged in. And yes, you're right. No HTTPS. Now,
Shows the key on the right, though.
that's helpful. Thanks, Chrome. I think that just means that something to do with passwords. Yeah, no, you're right. You're right. And no padlock on the left though, so no HTTPS. Now Tesco's have fixed this, but before they did, you could sniff the traffic off the network. So if you're on an open Wi-Fi hotspot, for example, in Starbucks, you can watch the traffic go by, and you can grab the cookies. And in this specific case, you could grab the cookies, take the session cookies, put them into your browser, and suddenly you're effectively logged on as the other person. And you might think, well, I don't connect to open Wi-Fi hotspots. Why, I wouldn't do that. But how do you know you're not connecting to something like a Wi-Fi pineapple, which is a device for impersonating networks that you know about? So your home network, or it's more likely going to be airport Wi-Fi or something that you've connected to in the past. All of that is in your phone or your laptop. As soon as your phone or laptop tries to basically sends out a probe request saying, hello, are you there, Wi-Fi network? This will say, yes, here I am. So this will basically respond as hundreds of different Wi-Fi networks, and you can then basically proxy all of the traffic through that, and you could potentially even strip the SSL out of the request and response, so that people end up on an insecure connection anyway. And that there are protections against that, which we can talk about in a second. But yeah, you might be unwittingly connecting to a hotspot that you weren't expecting. So I think of HTTPS as security pixie dust. It's pretty simple to do. It secures that traffic in transit. It doesn't really do much more than that, but there's not really any excuse not to do that now. So it mitigates all sorts of issues. There are even features in HTML5 that will only work over HTTPS, and so the geolocation, I think, is one example. So if you haven't got HTTPS, you can't use some of these features. So the whole internet is moving towards that, and it's not expensive to do. You can go to let'sencrypt.org and get a free certificate from them. That's pretty straightforward. Or you could put something like Cloudflare in front of your website and get it that way as well. They'll provide SSL certificates that they keep up to date for you. So there's lots of things that you can do. I think you need to make sure that you keep that up to date. So there are tools like SSL Labs, which will validate your SSL configuration, and you can get a score, which is great. Oh, good, we've got an A. That's buy box. Thank you very much. You can get your SSL configuration wrong if you basically take the configuration of a Windows server out of the box, for example. That's not going to be set up as it should be. So you have to pay attention to that. And I mentioned the ability to strip SSL from your connections when you're connecting to websites. Something like this might run a bit of software that basically intercepts the traffic, strips the HTTPS off your connections, and puts you back to an insecure connection. You may or may not have heard of HTTP strict transport security, which is a header that you put on your web server to send to your browser, which says this connection should always be over HTTPS, and that's a mitigation against having the SSL connection stripped off. So that's kind of something to think about as well. And then there's various details about that in terms of what happens the first time you come to the website. I'm not going to go into that, but look at HSTS, HTTP Secure Strict Transport Security, as a really great measure for making sure that you stay encrypted when you should be. And in that vein, I just wanted to do another poll. So if you go back to your phones, and I do that. So I'm really interested, bunch of developers in the room. Is HTTPS something that you worry about? Or do you think you can hand that off to somebody else? or 50. Oh, okay. You're looking perplexed at the front there. Have you got a different answer?
Well, no one really does it properly. Just check that technology is not in the room.
So are you saying that you could pass it off to somebody, but they wouldn't do it properly?
Well, it could be done by a client, it could be done by an infrastructure team, it could be done by a dev. Whoever gets there first.
Oh, okay, okay, interesting. Right, good, cool. So, okay, pretty mixed. Thank you very much. So I think that's really helpful because as devs, you know, we may or may not have to deal with that sort of stuff. So, you know, should I be talking about that more? Here's another lesson I think we can. Oh, hang on a minute. Let's come back to that. Here's another lesson. So, you know, it's not just companies that are under attack. The government are under attack as well. And they had a bit of a problem with people trying to brute force the passwords on their accounts in Parliament. Well, actually, more recently, it turns out that they give their passwords out pretty much to anybody anyway, which I think might change given some of the publicity that they've had recently. But you know, there are probably nation states trying to do it remotely, trying to log into their accounts. So I think there's a lot we can do there.
You're really into computers, huh?
Yeah.
What are you doing?
Dialing into the school's computer.
Did anyone ever have to put their phone into a...
They change the password every couple of weeks, but I know where
Just
they write
me.
it down.
See, in them days, you didn't even have a username. It's just half a factor, not even two-factor. Yeah, so passwords are a big problem. 81% of hacking-related breaches were leveraging stolen or weak credentials, passwords. So I think there's a bit of an issue there. What do we do? Well, we can help our users. We need and the latest advice from the cybersecurity in the UK and also in the US is that we want to be much less restrictive, be nice to our users, use technical defenses instead of big complexity rules. So no more complexity rules, allow long passwords, allow any characters, even emojis, allow people to use password managers because that's the great solution to having hundreds of passwords. And you're trying to encourage your users to not reuse the same password everywhere because that's leading to trouble because that password is probably going to be out in the open. Train users to avoid creating passwords that are guessable. That sort of thing. And I don't know if I might have just already said this, but I think that the advice that you have to change your password every month or every 3 months or every 6 months, that's now going away. You only change it if you know there's been a compromise. And I think one great approach is to ban passwords that are obvious. So, that password there is not a great password. It might have substitutions and numbers and symbols, but actually it's a terrible password. And actually I'll show an example of why that's such a bad password. I mentioned have I been pwned earlier. Troy Hunt actually released all of the passwords that he's collected over the many years of aggregating breaches. So if I type in that password that I just showed you, so capital P, A, couple of dollars, W, 0, RD. Wow. Yeah, no, that one's in the list. And so people will use lists like this to brute force passwords. So actually we can use the same list to prevent people from using those passwords. There's no reason why any of those passwords should be used. I mean, Buybox have been blacklisting passwords in that way since 2012, and we had a list of, say, the 1,000 most popular passwords. So you could do something. You could take 1,000, 100,000. You could even take the however many million that Troy Hunt has published, and stop people from using those passwords in your systems. In a similar vein, Uber had a bit of a problem recently where they uploaded credentials into their GitHub repository. So this was a combination of attacks. So somebody needed to compromise their developers, presumably, to get into their GitHub repository. So that was probably password reuse, one of their developers using a password which had been compromised somewhere else. Attackers get into their GitHub repository, and then they've got Amazon credentials or something similar in their GitHub. So it might be a private GitHub, but don't put secure information into it, because you never know when it might not be private anymore. You might make it public by accident, or somebody else might make it public on your behalf. So that's something else to be very wary of. Now, Amazon have got an extension for Git called Git Secrets, which you can plug into your Git running locally, and it will check to see if you're putting credentials into Git for, you know, Amazon buckets or something similar, or, you know, API keys. Now, obviously, that's really just relating to Amazon, but, you know, you might do something similar. And I think actually that there's even been mention of there are certainly bots looking at new commits into GitHub to look for this stuff on behalf of the baddies. So I'm sure the goodies might, you know, get there in the end and start doing the same thing. Is there anyone who isn't familiar with OWASP? Okay, a few people, probably half the room in fact. So OWASP is the Open Web Application Security Project. It's a charity. There's a set of user groups, and they produce projects, articles and documentation and standards around security aimed at fixing a lot of this stuff. Now, they've got a really well-known project called the OWASP Top 10, one of their most well-known, and that there's a new version out this year. And they talk about each of the vulnerabilities that are around and which are most prevalent. Which, you know, so the number one is the most prevalent, the biggest risk, that sort of thing. And they talk about how you fix that, what the risk is, and the ways you can go about fixing that within the top 10. And there are also much more detailed projects on. There's some great cheat sheets that are really helpful in terms of using. You know, you might have a problem with Crosssite scripting that you want to think about, so you could look at the cheat sheet for that, and it will give you all sorts of ways to test for it and ways to fix it. And there's tools like OWASP Zap, the Z attack proxy, which is a great little tool that you install locally, or you can run it from Docker. You basically proxy your browser through Zap, and it basically analyzes the traffic to and from your website. So you can be doing this while you're doing development, and it's basically looking for problems all the time, and then you can just basically look at the issues that it's found, and you know, come up with it'll give you suggestions for how you fix it. So I think from a .NET perspective, we're pretty good. There's a lot of mitigations in the framework. You know, so you might be already using lots of those. I think the key there is probably not to turn them off. But in terms of the number one vulnerability, SQL injection, not just SQL injection. You might be familiar with this cartoon from XKCD, which talks about little Bobby tables. If you haven't seen that, it's great. You look it up, but it's great. And that's talking about SQL injection using untrusted input from the user in ways that's really not expected by the application. Now, I'll talk a bit more about the fact that it's not just SQL, but certainly SQL injection is still a big issue. TalkTalk got fined £400,000 after this attack in 2015. This wasn't their first problem, so I think that's why. But that's the largest fine that the Information Commissioner's Office has passed down on a company. But under GDPR, that could be 20 million potentially. And it was a SQL injection attack. So they could have fixed it really nowadays. Instagram had a problem where a young lad from Finland found a way to delete comments with a similar situation, and this is a great one. So this is a election tampering in the US, and they found a SQL injection vulnerability there. And really, this stuff's been going on for a long time. This is Frack magazine, which is an old school online magazine. This is actually from 1998, December 1998, and in there they talk about SQL injection. This is not a new problem, and really something that we should all be well aware of. So I'll talk about it from a SQL perspective. So you've got a user form, a username and password form here on your website. You take the data and you pass it into a string with a bit of string format, and if somebody passes in the right format of injected code, you end up not requiring a password at all in that SQL. So this is a fairly well-known problem, and I hope in the .NET space we're probably not doing that anymore. But it's worth mentioning, and that untrusted user input could come from a form, but it could also come from a query string or a cookie or an HTTP header. So you need to be thinking about more than just this scenario here. And as I say, it's not just SQL. So there are attacks against Mongo, and there's probably going to be attacks anywhere where you're mixing commands and data in that way. So yes, parameterized queries, use least privilege. So only allow access to the data that the user should be able to access. I mean, maybe it's read only, stop them from deleting stuff, and you can whitelist input or validate input to prevent this kind of thing happening. Another lesson. So we got any Ashley Madison customers in the room? So this one, they had all sorts of problems with their systems, but a flaw in their authentication meant that the passwords were compromised. Now in this case, they'd actually gone to quite a lot of trouble. They used bcrypt to store their passwords, but unfortunately somewhere else in the code they'd used an MD5 hash, which is trivially easy to get the password back from it, even though it's supposedly a one-way function. So what do we do about that? Well, in this case, I'd probably say don't do the authentication yourself unless you really know what you're doing. So you can use a separate authentication provider. It might be ASP.NET Identity at sort of basic level, but you might use something like Identity Server, or you might just allow Facebook or Google or one of the authentication providers to do that authentication for you. Or if you are going to roll your own, make sure you understand how you're going to secure those passwords so that they're not in plain text and not reversible encryption, and using a suitable algorithm. One thing I do like to mention, which doesn't come up very often, I think, is crypto agility, if you are storing your own encrypted data, right, be it hashing or reversible encryption, store it in a way that you can change that encryption going forwards, so that as attacks get better, and they always do, you can change your algorithm to adapt. I think that's a really helpful thing that I don't see enough of. So cross-site scripting, this is a bug that happened to eBay, again 2016. This has dropped down the OWASP top 10. This has dropped from 3 to 7. So you might think that actually it's going out of fashion. And again, in the .NET space, there's output encoding built into the framework. If you're kind of using it in the right way, it's almost safe by default, and you're probably going to be all right as long as you're not switching that sort of thing off. But I think this year there's going to be a lot more people looking for these vulnerabilities in websites. I'll talk about why in a minute. So just a really quick look at cross-site scripting. So here's I'm accepting a username here, and in that username I'm passing in a bit of script, and in a cross-site scripting attack, the browser receives that bit of code and inserts it into the HTML, and suddenly that JavaScript runs and steals the cookies. So again, it's untrusted data from the user. There's variations on the attack. It might be reflected, so you send something to the web server, it sends it back to you. I'll show you that in a second. Or it might be you might persist it into your database, and then it comes back to bite you later. But it's basically allowing arbitrary JavaScript to run in your browser to attack user sessions, deface websites, insert hostile content, redirect users, install malware, that sort of thing. And again, it comes back to not trusting that user input, escaping it using the correct encoding for HTML or CSS or JavaScript. And the framework will help you there generally, but you can't use some of the HTML encoding in .NET in the JavaScript, because that wouldn't kind of work. You've got request validation in ASP.NET. Don't turn it off. If you do need to turn it off for the minimum amount. Don't turn it off for the whole app. Really be aware of what you're doing there. And content security policy is another great technique for dealing with cross-site scripting. And I think if you can build that into your app early on, it's really easy to do. Again, it's another HTTP header that you serve with your application, and in that you're specifying where you can run JavaScript or where the trusted JavaScript comes from. So you can turn off inline JavaScript, and that basically that stops pretty much most cross-site scripting attacks. So I just wanted to show you the power of cross-site scripting. I'm gonna go over here. So this is Bob's Discount Diamonds. This is a .NET app that I wrote. It's basically deliberately flawed just to demonstrate some of these problems. So you can go around and look at the various diamonds that are available, and you can send a message here. I can say hello. It says hello back. So what I might do here is actually, let's have some JavaScript in there. And because I've done the wrong thing in my code, when it comes back, it actually sends, it's put up an alert box. Let's just zoom in. So that alert box becomes because I've allowed that JavaScript to run inside my application. And once you can do that, you can do all sorts of things. So let me show you. I'm going to grab this bit of script. So what you get back in the browser is it's it's nothing to see here, which is great, except if I go over to this other application, this other web browser, which is here. This is a thing called Beef, the browser exploitation framework. So what this has done, I've run that JavaScript and it's now running in the browser, and that has allowed me to well, that bit of JavaScript is communicating with this virtual machine running up in Azure, and hopefully I should be able to send commands to this browser. So there's all sorts of things that you can do in here. You can get information about what's running on the browser. You can, let's move that out of the way. You can, the social engineering things are quite interesting. So if I do that, send that over there, zoom out, hopefully in a second, oh look, there's Clippy. So if I click yes, I can. It will let me download an executable, and who knows what that executable is going to do? Could do anything, right? Or maybe. So let's see, that Google one's quite good. So once you've got JavaScript running in the browser on somebody else's browser, you can do all sorts of good things. So let's see if this is going to redirect. Okay. So would you type your username and password into that? Maybe you would. And as soon as you do, it's going to come back into my console over here, and then I can log into your Google Mail. So that's the power of cross-site scripting, and I think, yeah, once you're there, you can do all sorts. I mentioned that I thought we were going to see a bit of a comeback for cross-site scripting, and the reason I think we're going to see a comeback for cross-site scripting is that you can now run Bitcoin mining in the browser. So I saw a tweet today where somebody had gone to a Starbucks in Brazil, and they suddenly found that their browser was mining Bitcoin for somebody else. And the reason it did that is because, well, in that case, it was an open Wi-Fi hotspot. So they'd manipulated the HTML as it went through the open Wi-Fi hotspot, similar to what I could do with this. But if you've got a cross-site scripting vulnerability in your website, if someone can leverage that to send basically the JavaScript for Bitcoin mining into your customers' browsers, I think there's a real scope there for a lot of people to do a lot of Bitcoin mining. And I think that's why cross-site scripting isn't going to go away just yet. The next lesson, and we're getting pretty close to the end actually. For me, it's continuous improvement. One of the problems I think we've got is that we build software and it's finished and we deploy it and we're done. And unfortunately, the rest of the world doesn't stop just because we've finished with our project. So dependencies in our code have vulnerabilities in them. Our own code may not have vulnerabilities in them, but is the jQuery library that you're using up to date? What about some of the other bits and pieces that you're using? Do you need the latest version of React? Is there a problem with that? So I think really we need to keep an eye on those dependencies to keep our applications secure. And I think for me that's really important. Now GitHub actually have a project which I think is brilliant, and that will scan your code in GitHub, and it will look at the dependencies and it will tell you if some of them have vulnerabilities based on the CVE databases. The CVE database contains all of the known vulnerabilities in various code, and they're actively scanning to detect that, which is brilliant. But the language support is limited. So I think if you're in JavaScript, you're probably okay. But and there's a few others that are coming. But I think there's a bit of a way to go there, and I think that's really helpful. The other thing is catching problems early. So here's your development pipeline. You plan, code, test, release, deploy, operate, perhaps. So you've got your dev and you've ops. Oh, maybe you're now DevOps. But where does your security happen? Does it happen here? Maybe. Does it happen here? Possibly. Really, it needs to happen here. So in the same way that you involve dev and ops together, and you've probably got QA in there too. So I've heard people talk about dev QA ops, or I think it needs to be dev QA, dev sec QA ops, etc. There's no point having brought these two silos together and forgetting about the rest. We need to include QA too. I think you're probably undoubtedly, if you're doing DevOps, you're undoubtedly involving QA anyway. So bring security in as well, get them in up front, and yeah, I think that's the way to do it. We know that bugs cost more money the longer you leave them. It doesn't matter whether they're feature bugs or whether they're security bugs. Get them early. One last poll. Okay. I'm really interested to know what the next thing you're really interested in learning about. And I've put a few options down there. It might come down to other for everything, but I'd be fascinated to know. This one's multiple choice, so you can pick more than one. Oh, across the board. Look at that. Let's see what the answers are. Okay, cool. So I've done a lightning talk on OWASP that, which will come into the security testing thing. And I've got a talk on authentication that I can do as well, so that's great. Thank you very much. There's some resources on my blog at robinminto.com/talks/fail. Time for questions. Has anyone got any questions? One question.
You talked about stored secrets in some way being evolvable as algorithms improve. Can you elaborate on that a little?
Crypto agility.
I think that's the word you used.
Yeah. Okay, so if you are, let's say you're storing passwords in a database, and you know that bcrypt is a great algorithm today, and I mean bcrypt has actually got some features built in to enable crypto agility. So I'll talk about both. Bcrypt has a work factor, so you can vary how hard that algorithm works to hash your password. So it might actually do, say, 10,000 iterations of the algorithm to give you the hashed result. That means to get that, if you want to brute force that algorithm by where you take the plain text and you put it into the algorithm, you get the hash value out, and then you compare it to the one you're trying to brute force. And you do that with a dictionary or a big long list of combinations, and eventually you'll get the answer. If you make that algorithm slow to run, say 10,000 iterations, it's going to take you a long time to brute force the result that you're looking for. And so in bcrypt you've got a work factor, so you might increase it to more than 10,000 iterations, 100,000 iterations. So as processors get faster, as you start throwing more hardware at it, you increase the work factor, and it makes it means that the speed that the algorithm runs as processors increase, you can tune it. So the attacks don't inevitably get faster. And then crypto agility is kind of the next level of that. You know you're using bcrypt, but actually now in the future you want to move to there's another algorithm called scrypt, or perhaps I think it's called Argon, which is another next generation password hashing algorithm. So if you store the fact that you're using bcrypt in your database alongside your hashed value, when you want to migrate to another algorithm, you could actually combine the hashing algorithms. So you have bcrypt plus scrypt, and then you know that you've used both algorithms. So you then do that when the person logs in. You can apply both algorithms, or if you haven't used both algorithms, you're still using just bcrypt. For each record, you know what to do, and so that I'm not sure if I've explained that particularly well. But it's basically gives you the ability to select the algorithm on the fly as somebody logs in, and then as they log in, they've just given you their clear text password to compare. You would then rehash it with the new algorithm, and then store that, and you could then say, okay, so this person is now using scrypt, this person's using bcrypt, this person's using scrypt. So yeah, that's one way of doing that. But you can use, go on.
Well, I was just going to say, so that means that all the people who don't log in very often now the older it's inherently their accounts are less secure.
Yeah, so that's why I would actually use a combination of. So you could say this person has used bcrypt. I don't know what their password is, but if you then apply scrypt on top of that, you've kind of got this hybrid approach. And so it's protected by scrypt and bcrypt, but that's probably overkill in the end. And you might want to normalize down to scrypt for everybody as they log in. But certainly those older accounts, you would be protected by both. And then once you've got through, well, I mean, you might never get rid of that combination, but certainly you might want to get rid of that just for the speed of processing for people logging in.
Yeah, but you don't care about it because by definition there's people who never log in.
Yeah, the problem there is going to be if somebody wants to cause problems with your website by sending you login requests for people who don't exist, or sorry, who aren't logging in. But you know that kind of extra processing power might be a problem for you. You might be paying the cloud provider for it, for example. But you can do the same with symmetric algorithms as well. So you might know that you're using AES 128 now, but in the future you might use something completely different. And if you know what algorithm you used because it's on the record, you can then change that as you move forward.
Could you say a bit more about the process whereby some mysterious piece of kit can remove? You mentioned that was about when I came in. I was late. So stripping HTTPS back to HTTP.
Yeah.
The whole point of HTTPS that you know it's encrypted right from end to end.
So if you've fallen foul to something like this, so your traffic has to be being proxied by someone who is up to no good. So it might be an open Wi-Fi hotspot, something like this. There is a potential at any open Wi-Fi hotspot for your traffic to be diverted through an attacker. If they are diverting your traffic, they've got control over it. So you make a request to https://twitter.com. They see that go by. They will probably make that request to Twitter from. So your machine says here's the request. They can basically do what they like with it. So at that point, they could potentially send it to Twitter as HTTPS or not, and then capture the response and send it back to you. Often you will strip the HTTPS off, because that then gives you just complete flexibility over what's going on. Your browser may have requested HTTPS in the first place, but because all of the links in that web page are basically being manipulated by the attacker, they can do kind of whatever they like with it, really.
I'm starting from an assumption that, we'll stick with Twitter, if my browser thinks it's talking to Twitter, then how did my browser come to trust that certificate?
Yeah.
If it didn't come from Twitter.
Yeah, that's a good point. I think, let me think through this a bit. I think we would have had to intercept the traffic before it got to that point, potentially.
So does that mean I have to start off with HTTP and then somehow that device stops me getting to proper HTTPS?
I think probably the way it would happen, if you actually go and type in HTTPS, you'd probably be safe. But how many people do that? You know, you just go to your browser. I mean, a lot of people just type Twitter into Google, right?
Yep.
They search for it in Google, or you type it into the address bar. So even though if you don't put that HTTPS on the front, your browser goes off over HTTP to Twitter. Twitter then redirects you. It's at that point we've got the opportunity to not allow that redirection. So we can basically get in the middle there. Okay? Thank you very much.
Thank you.